Hey, this is the beginning of Unit 14, which is our last big unit of the year. And this one is all about probability, which we've kind of already started and we've done a lot with the counting outcomes unit. And the reason why we're doing this in geometry class is because in Minnesota, we are required to learn about probability in high school, and we don't have a probability course. So it gets covered at the end of geometry each year. So let's dive in to our note-taking packet here. We'll start with 14.1, which is probability and odds. And our objective for this lesson is really just to learn the basics. You will notice that throughout this unit, each lesson is going to kind of build on the previous one, and it's going to get more and more complicated. So we're going to start with kind of the fundamentals of probability. Now, for this exploration part, this is where you are going to list anything that you already know about probability. And I'm sure you already know quite a bit. So if you could pause the video right now and list some of those things, that would be really great. That'll help your brain get started with the probability unit. And then we will go into a more formal mathematical definition here. Probability is basically the likelihood or the chance that something will happen. And it can range from very, very small or not likely at all the way to it will definitely happen. And it says that on the front of your packet. It kind of gives you an idea of what to look for, if it's likely or somewhat likely or not likely at all. So this would be never, and this would be always. So the cool thing is that when you are answering a probability question, the answer will always be between 0 and 1. If you get an answer of 7, you probably did something wrong because your answer should always be between 0 and 1. So as far as kind of like our formula goes, I really don't even like to call it that. But it goes like this. The probability of being successful is equal to the number of ways that you can be successful divided by total number of outcomes. And that's what we spent a lot of time doing in the last unit, was just counting the outcomes. And that leads us into probability very nicely. So this first example using the spinner, this one is really basic, really pretty easy. It says, what is the probability of winning 10 tokens? So we want to find how many ways we could be successful. So right here would be a winner, right here would be a winner. So the probability or the number of ways we could be successful is 2 over the total number of outcomes. So we would need to count all of the possibilities. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8. So 2/8. And if you can ever reduce your fractions, you should do that. So 1/4. 1/4, 1 divided by 4, that would be 0.25. I'm not going to make us do this every time, but just as we kind of get the hang of it here, 0.25, which is equal to 25%. So somewhat likely, definitely not impossible. 1 out of 4 times you spin the spinner, you would expect to land on 10 tokens. Okay, probability of winning 5 tokens. Well, there's only one spot where you could win 5 tokens, so that would be 1/8. And probability of winning free ice cream. Looks like that's this one right here. I should maybe change colors. Free ice cream, so once again, 1/8. Can't reduce it. You could turn it into a decimal if you wanted to. It doesn't say we have to, but it would be 0.125, which would be about 12.5%. So definitely not as likely. All right, moving on to the next question. It says sample space and probability. And it says make a sample space for flipping a 4-sided die and tossing a coin. So you could make a tree diagram, or I think it's probably easy enough to just list the sample space. So you could get heads and a 1, you could get heads and a 2, you could get heads and a 3, you could get heads and a 4, or you could get tails and a 1, tails 2, tails 3, tails 4. You get the idea. Okay, so total number of outcomes would be 8. And that'll help us as we go through these next questions here. So it says, what is the probability of flipping a tail and getting an even number? So I'm going to circle those ones. So tails and even number. So tails and a 2 or tails and a 4. So there are 2 possible ways of being successful over a possible 8 outcomes. And 2/8 is the same as 1/4. So there's the answer to that one. And then I'll switch colors here. It says, what is the probability of flipping a tail and getting a number less than 4? So we need tails that's less than 4. So tails less than 4 would be tails 3, tails 2, tails 1. So 3 out of 8. Okay, when you see the word and here, that means basically you need both of these, tails and even. So I'm just going to remind us that that means both. All right, moving on to page 2. Now odds is a little bit different. Odds is usually written as a ratio, and you'll usually see it like this: success to failure. Okay, so instead of successes over total outcomes, it's number of ways you could be successful. 2, we would read this 2, the number of ways that we could fail. Now, the cool thing is success plus failure is always equal to your total number of outcomes. So I always find probability first, and then I'll convert it into odds, and we can do that when we do the examples here. So if we look at a practice problem, it says a person buys a bag of Jelly Bellies and opens them up. Inside there are 8 candies, 5 of which are blue, 2 that are black, 3 that are green, and 6 that are purple. A person picks a jelly bean at random. Oh, 8 red candies. Sorry, I read that wrong. I was like 8. Okay, so the probability of choosing a blue, red, or green. So first, over here where it says frequency distribution, this is just where you kind of summarize your work here. So we're just going to do this. We're just going to say red is 8. Red is 8, and blue is, and I have to write that out because we have blue and black. Blue is 5, and black is 2, and green is 3, and purple is 6. Okay, and that's helpful just for organizing our work, so we don't have to keep reading through the whole word problem each time, and also so we can find the total number of outcomes. So if we add all those together, 6 and 3 is 9, 10, 11, plus 5 is 16, plus 8 is 24. So we have 24 total outcomes. So now it says, what is the probability of choosing a blue, red, or green? So blue or a red or a green. So that's quite a few. That's all but 8 of them. So that would mean we would have 16 possibilities of being successful out of 24 total outcomes. And that can be reduced. Each of those can be divided by 8. 16 divided by 8 is 2, and 24 divided by 8 is 3. So the probability is 2/3, which is pretty good. Okay. And then it says, what is the probability of not choosing red or blue? So we want not red and not blue. So we would just be looking at those 3. So it looks like there's 5, and 6 is 11 out of 24. And 11 is a prime number, so there's not really anything we can do with that one. We'll just leave it as 11 over 24. Okay, now we're getting to some odds questions. So it says, what is the odds, or what are the odds of choosing purple? So I always first would find the probability of purple. So off to the side here, I'm going to do probability of purple because that's easy. We just find the total number of purples, which is 6, over the total, which is 24, and then reduce it. Both of those are divisible by 6, so we're going to end up with 1/4. That's our probability. Okay, now to get odds, for odds, the first number is the top. Successes was on the top, and successes comes first. So it's going to be 1 to something. Okay, now remember, successes plus failures is always equal to the total. So 1 plus what number gives you 4? Think about that for a second. 1 plus what number gives you 4? Well, 3. So the odds would be 1 to 3. Okay, so I'm going to make a little note of that. So when you're going from probability to odds, the top number is the first number. So this is for probability, and this is for odds. Okay, and then to get the second number, so like we got the 3, you're going to start with probability, and you're going to do bottom minus top, and that will give you that second number. So let's do odds of choosing a red. Let's try that one more time to make sure we have the hang of it. So odds of choosing a red. First thing I'm going to do is find the probability. So there were 8 total reds out of 24 total. So I'm going to do probability of red first. Probability of red is 8 over 24. Both of those are divisible by 8. So we're going to get 1/3. And then we're going to convert that to odds. So the top number is the first number. And then the second number is bottom minus top. So 3 minus 1 is 2. Every time, these two numbers should be equal to the bottom when you add them together. 1 plus 3 is 4. 1 plus 2 is 3. And that will work every time. Okay. If you think you have the hang of it and you want to try the practice, I think at this point you could probably go for it. Or you can keep listening here and make sure that you really have the hang of it. I know this video is getting a little bit long, so you can make the choice at this point. So letter B, it says you're starting a family and choose to have 3 children. What could your family look like? Write out all of the possibilities. So I know that there would be 8 outcomes because you could have either a boy or a girl. And for your first child, a boy and a girl, a boy and a girl. But to organize this, I'm going to make a quick little tree diagram. So first child, second child, third child. And now I'm going to list them all. So we could have boy, 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 girl. We could have boy, girl, boy, boy, girl, girl. Or we could have girl, boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. So 8 possible outcomes. Okay, so what is the probability of having 3 boys? Well, there's only one way that you could have 3 boys out of 8 possible outcomes, so 1/8. What are the odds of having 3 boys? 1, 2, 7. Where am I getting that? Those guys are the same. This is bottom minus top, so 8 minus 1 from your original probability. Okay, what is the probability of having 1 boy and 2 girls? So we need to find all of them where there's 1 boy and 2 girls. So here's one, and here's one, and here is another one. So 3 different ways that that could happen out of 8 total outcomes. The odds then would be 3 to 5. All right, and then it says, what is the difference between probability and odds? Probability is success over total. Odds is success to failure. It's a little bit different, just to remind you there. All right, and then letter C here. This is going to take up a little bit of our time here. It says you roll 2 dice, fill in the table to make the sample space. What is the probability of rolling doubles? So I'm just going to fill this table in. You may want this for future reference anyway, so let's get that filled in. All right, so what is the probability of rolling doubles? So all of the doubles, I think, are going to make a nice diagonal line here. So it looks like there's 1, 2, 3, 4, 5, 6 ways to roll doubles out of a total 36 outcomes. And I just got that quickly by multiplying. There's 6 ways to get the first die and 6 ways to do the second die. So 6 times 6 is 36. And that reduces down to 1/6. Okay. Now the next one is, I'm actually going to skip down to letter C, where it says, what are the odds of rolling doubles? So since we already have the probability, it'll be easy to do the odds, just 1 to 5. Okay. And then letter B here, what is the probability of rolling only even numbers? Only even numbers. Let's see if we can find a pattern. There's not going to be anything here because there's a 1 in each of those. Now in the 2 row, 2 and 2, 2 and 4, 2 and 6. Can ignore this row because there's a 3 in each of those. And then we have 4, 2, 4, 4, and 4, 6. I think you're probably starting to see the pattern here. Nothing in the 5s. And then 6, 2, 6, 4, and 6, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9 ways to get only even numbers out of a possible 36. Divide each of those by 9, and we're going to get 1/4. All right. And then what are the odds of rolling at least 1, 1? At least 1, 1. So we got to find everything that has a 1 in it. So there, and there. All of those have at least 1, 1. So altogether, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 out of 36. Now, so far, that's just our probability. We want the odds. So to get the odds, we start with 11, and then we need to do 36 minus 11, which is going to be, what, 25? So 11 to 25 would be our odds. All right, so that video is long. Some of these will be a little bit longer here, but I think that we can handle that. So go ahead and get to work on 14.1. Good luck.